is a basic probe orientation and settings of the ultrasound machine. This will be part of a series. This is part 1. So whenever I will be doing this demonstration using a curvilinear probe. This is the curvilinear probe, and whenever you pick up a probe you will see there are different markers. We have a marker there, and this corresponds to the marker on the screen, and when you are scanning, that goes to the patient's head when you are in long section, or the patient's right when you are in transverse. So I will demonstrate this now. I'll just put some gel onto this obstetric phantom. I'm using the obstetric phantom, but this is exactly the same for all types of scanning: vascular, general medical, musculoskeletal, all types apart from echocardiography. So the marker goes to the lady's head, and you can see here we have the picture of the fetus of using the head phantom. Okay, so we're going to go through basic orientation. Okay, now this part of the image represents the patient's skin. This side of the image represents the maternal head. This is the maternal feet, and this is whatever we are pointing at, which will be the maternal back. This is in long section. If I now turn the probe into transverse section, what I have to do is turn the probe through 90 degrees anti-clockwise. This is still the patient's skin. This is still what I'm pointing at, which is the patient's back, but now this becomes the patient's right, and this becomes the patient's left. Now this is very important because as I demonstrate, if I come back into long section by rotating the probe clockwise, if I turn the probe anti-clockwise, the image will be very similar, but everything will be in the wrong place. You will think this is the patient's right, when in reality it is the patient's left. As you can see, if I touch there, so I'm touching the left side of the phantom, but we think it's on the right side of the screen. So it's very important that when you turn anti-clockwise. And now we can see that when I touch, it's on the right side of the image. It's exactly the same thing when you were in long section. So if I turn it clockwise again, we will have, this will be the bit of the lady's head, and this baby would be in the breech position. But if I turn the probe the wrong way around, so if I turn it anti-clockwise there, and if I now put the probe on the wrong way around, you will see, now I realise this because the probe is moving in the wrong direction, but somebody with less experience won't realise that. And what you can now see is that baby is now in the cephalic position. So a simple presentation scan can become very, very complicated, and you can actually get it the wrong way around. Okay, so let's go back to how we should be. So the marker to the lady's head, okay, putting that on, and there we can see the fetus is back to the normal orientation. So what we will talk about now is some of the basic controls that you have to understand. The first one I'm going to work is this one here, which is the depth. Now this is a Toshiba machine, so the buttons will be in certain places. Different machines will have a different layout, but they will all have these same buttons that I'm going to talk about now. So this is the depth, and what this does is it allows us to see not as far into the patient, as you can see here. Okay, so we're just seeing a few centimetres. These markers on the side are 1 centimetre, so this is allowing us to see 4 centimetres into the patient. And then if I turn it the other way, we can see much further into the patient. We can now see 15, 18, 19 centimeters into the patient. Okay. What's important with depth is that you always see the skin surface. Okay. You can zoom the image up as well, but we're not going to talk about that at the moment. This is depth, and this just allows us to see further into the patient or not as far in. What you always want to do is you always want to just have the depth set so the area of interest is what you're seeing. So if I wanted to see the full fetus, I would change my depth like so we can see the full fetus. If I was wanting to see just the fingers, then I would reduce my depth more, and as you can see here, you can see much more detail of those fingers now because we've optimized the depth. Exactly the same thing with the baby's face. If I was wanting nose and lips, I would have it set like that. If I was wanting to see the head, I would increase the depth so I can see the baby's head. And you always want to have the depth set so it can show you exactly what you're interested in. Another control that we need to talk about is focus, which I'm going to change with this wheel here. I'm going to change the focus there. Okay, and then again you want the focus set at the area of interest. So if I'm interested in the face and nose, you have the focus set at the face and nose. If I want it at the fingers, you set it at the fingers. If I was wanting it set at the back of the baby's head to measure nuchal lucency, I would bring the focus down to the back of the head. Okay, now what that does, putting the focus in the right place gives you good lateral resolution, which we'll come to in a later video, but you have to put the focus at the point of interest to give you good lateral resolution, which is the ability to see two things side by side. Okay, so we've talked about depth. Okay, so I will optimize it to look at those fingers. Okay, so my focus is in the right place. My depth is appropriately set. What I'm now going to talk about is the gain. Now the overall gain makes everything white or dark. Now I'm not putting any extra power into the patient. This is a post-processing feature, and what's happening is the gain is amplifying all of the returning echoes. So all of the echoes which come back to the probe, the gain amplifies them by the same amount. Okay, and it makes everything whiter or darker. If it's too white, as you can see here, it actually saturates. Okay, all of a sudden everything is too white and black starts getting filled in. If it's too dark, if it's too low, then we start getting to the point where we can't see anything. We now can't see that phase. So you have to have the gain set appropriately. You want it turned up to the point of just before we start getting noise. Okay. So I'm going to look at these fingers again now. Okay. And the other control we've got is this one here, time gain compensation. Now this is exactly the same as the gain. It's post-processing, it's amplifying the returning echoes, but what it's doing is it's allowing us to amplify different depths by a different amount. So if I just get a bit more depth so we can see this, and then I'm just going to concentrate on these two sliders here. If I put them too much, you can see how only the middle of the image is amplified. If I bring them the other way now, you can see only the middle of the image is having the gain reduced, and this is particularly useful when you're actually doing scanning behind fluid-filled structures. So when you're doing gynae scanning, you would alternate this image to actually reduce the effect of posterior acoustic enhancement. Okay, machines are quite forgiving nowadays. The auto gain is actually quite good, but there is still times when you want to fine-tune the image. Okay, as you can see, I'm reducing for different depths now, and that has given us that fine-tuning of the gain. And then I'm going to start bringing it back up again. Okay, so that is the time gain compensation, or TGC for short. So I'm just going to bring my image back to normal again. So what have we talked about so far? We've talked about overall gain, we've talked about the depth, and we've talked about focusing. Okay. One more thing I want to talk about in this part 1 video is the scan range. Now what we can do with the scan range is, at the moment it's set for 100%, but if I turn this, the generic term for this is sector width. This machine calls it scan range, but they all do the same thing. And what I'm going to do now is I'm going to reduce the sector width. And what this does is it allows us to see the structures that we're interested in more detail. So I'm going to reduce that sector width. So if I was only interested in the nose and mouth, what I would do is I would optimize my depth, put my focus in the right place, and narrow my scan range or my sector width down, so I'm only sending echoes and only receiving echoes from the area that I'm interested in. Again, if I wanted to look at the fingers, I would do exactly the same thing with the fingers. Okay, alright. Now, a side product of this is the fact that our frame rate has also increased. Okay. Now, frame rate is the number of frames per second that we actually get, that the image is made up of. Okay, and this is important. The human eye can only see 20 frames per second, so as long as that frame rate is above 20 frames per second, then we see a real live moving image. You can see as I'm increasing the sector width, the frame rate is then reducing, and this is because the machine has to send echoes across the full scan range. Okay, and I'm moving it. We've got a frame rate there of 27, so as I'm moving the probe around, we can see that that image is keeping up with my hand. Okay. Now, one thing we have to think about with obstetrics is, if you have a fast moving structure like the fetal heart, you need a faster frame rate. So what you do is you reduce the sector width, and this is why you will see that all of the cardiac settings on an obstetric machine will have, or an obstetric preset rather, will have a narrow sector width to give us an increased frame rate. So that's it for this part 1. We'll be doing another video soon where we start talking about more advanced features and controls. Thank you.